catch up to you guys here. So on this first problem, what's n?
44.
It's crazy. P, of course, is 0.152. I'm going to show you this once because either you're going to like it or you're not going to give a shit about it. But notice how we have to subtract from 1 a lot. I want to show you this cool little trick. And I know you got a calculator. And again, I don't care. You should know this as a human. 1 minus that, here's a little nice shortcut. What makes 1 become 9? What makes 1 become 9? 8. What makes 5 become 9? 4. What makes 2 become 10? 8.848. Isn't that what Q is? If you think about it, the reason that shortcut works, if I have to do, real quick, I just suffer, I don't care, I'm a math teacher, just suffer me for a second. 1 minus 0.152. If I had to do this by hand, look at all the freaking borrowing that I have to do, right? Subtraction is how far two things are apart. So if I make this one go down to 0.999, I can make this one go down to 0.151. And the answer is the same. So that's why you think, what makes this become 9? 8. What makes this become 9? 4. What makes this become 10? Because that involves that here, to be honest. 8. The 2 become 10. That's why at the end you do the 10 now. So that's nice. So if you don't care, that's great. If you do care, if that is interesting, you've never seen it before, I love that I've just given you that. There you go. You're welcome. Pretend like most of you care. And then, now I can use, obviously there they were anyway, already there for you. So let's see, how do I set up this first one here? 44. Choose 7 of them to smoke. So what's P? And how many of those do I want? 7. It's crazy. Q is 0.848. And how many of those do I want? The rest. 44 minus 7. N minus X. So a real quick check is always these exponents have to add to be this. And let's see, when you plug all that in the calculator, what does it look like? 44 choose 7, move over times 0.152 to 7, 0.848. Shit and a half. I mean, thank you. So you guys got 0.1611?
What'd you press?
Is that insert?
Insert, yeah. You got insert and delete. I was about to say, just like you do on a typewriter. Holy crap. Typewriters. I love it. Typewriters and 8-tracks. No? Okay.
Sounds like the name of a band.
Yeah, I like it. That is good. I like that. 8-tracks. Acoustic band. So we get 0.1611. So far, so good? Is that all right? Of course, this is the one that freaked everybody out. I did this on purpose because you got to understand what that means when you get that out of your calculator. So this again will be 44. I still got 44 total San Diegans. But now I want to choose none of them. So that'll be 0.152. I got no successes. 0.848. I got all of them failures, which in this context is actually the reverse of what it sounds. Right? If you do smoke, I feel bad for you. I'm glad I never started smoking, to be honest. But some of you guys are like, shut the... I'm like, all right, you can do what you want to. So what do you get when you do this? You get that weird thing come out of here. Times 1.152 0 times. By the way, what is something to the 0 power? 1. If it was 0, the answer here would be 0. So I really don't have to type that. How many ways is there to choose nothing from 44? One way. I choose nothing. So that's also 1. So really all I needed to do is put this last piece in, 0.848 to the 44. So this is where you get this freaky thing. Do not write 7, my God, because that means there's a 700% chance of that happening. That is an issue. Some of you guys on the probability quiz put 1.6 down and didn't. Just say, if you can't see what your problem mistake was, say, I know it shouldn't be bigger than 1, Jeff, and I'll take off less points, because I'm like, thank God you at least realize that. You guys kind of with me? Don't just leave an answer like 1.6 and just leave it like, that's good. That's bad. Where am I? Oh, so this means move it back 4 times. The funny thing is, I'm always going to have to move it back once. So really, I just put 1 less 0 in front of it. I'm going to move it back 4 times. Once, and then 1, 2, 3, there'll be 3 zeros in front of the 7. You guys see that? I'm trying to give you a little shortcut for the scientific notation movement of decimals. So this is just going to be 0.0007. Plop. So there's a very low chance out of a random group of 44 San Diegans that none of them will smoke. It's a very small chance. So probably that at least one of them smokes is 1 minus none of them smoking, because they're the opposite of each other. We've seen that many times before already. So it's a very, 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 very good chance I would put money on there being at least one smoker out of any random group of 44 San Diegans. This is from Gallup, and I think this is at least a couple years old, to be honest, but oh well. It's just a worksheet. It was true a few years ago. Now, the part that I want to talk about, I wanted to put this down here. I wanted to see who had an issue with the fact that I haven't even discussed why that's the formula yet. And some of you guys are just like, well, it's just plug and chug shit. I don't know. But think about it. Think about it. I like to pick on, who do I like to pick on nowadays? Because a lot of you guys might not even know. You guys know Shaquille O'Neal? You guys know he used to play basketball, not just talk about it, right? And he used to suck at free throws really bad, right? I'm a Celtics fan, so he was actually a Celtic for a little while. It really tripped me out. But all that stuff aside, right? Let's say that Shaquille O'Neal makes 30% of his free throws. That's really generous. And he takes 20 free throws. On average, how many free throws should he make? He makes 30% of his free throws. He takes 20. How many would you expect him to make? 30% of 20. N times P. So that's why that's the average. Now, why is the other thing the standard deviation? Just because at this point. I can't really. The math behind that one's a little more interesting. So we're just going to accept that one. But the mean formula makes complete sense. So in this case, it'll be 44 times 0.152. What do you guys get? 6.688? So I'd expect an average of almost 7 San Diegans out of any group of 44 that would smoke. Does that mean I always have to get 7? No. So what we're about to get into in a second is this question of, let me ask you this. If I flipped a coin 1,000 times, number one, I've got to analyze my life, really. But number two, how many heads would you expect to show up? Now, if you got exactly 500, that would actually be a little bit freaky. You would expect close to 500, right? 500 actually is the most likely outcome, but even that is a very small probability, to be honest. So what would be unusual then? The idea of unusual. Would 503 be unusual? I think most of us would agree, no. Getting 503 heads out of 1,000 flips would not be like, holy shit, right? So what's that line where unusual starts? Is it 515? Is it 580? Is it 700? I mean, if you flipped a coin 1,000 times and got 700 heads, that is evidence that something is wrong with that coin. It's not proof, because it's possible to get 1,000 heads in 1,000 flips with a perfectly fair coin. That is possible. That is not impossible. It is very unlikely. So if it happened, I'm like, well, that's somebody been screwing with this coin. Somebody's using this for some reason. You guys, they've weighted it somehow. All right. Maybe. I don't know if most of you guys are like, show him nothing. Okay. So this standard deviation formula, now please take a minute and realize that's the most fantastic mean and standard deviation formula we've had yet. I mean, that's beautiful. So binomial probability things Let them be that beautiful. It's no tables to make. So what's this going to be? Square root. Some of you guys might realize that's NP, which you already know, but let's pretend like we didn't realize that. 44 times 0.152 times 0.84a. What do you guys get there? 5.6714. Whoa, what did I get? I get this, 2.381.
Yeah.
Oh, no square root?
It is
Yeah.
square root.
No, I'm with you guys. I'm talking.
Oh, okay.
So you got something different. So 2.381. Bless you. Please realize I'm going to continue to take points off if you round the standard deviation to too few decimal places. You either realize it's because I'm trying to not let you make error mistakes that propagate, or you can hate me for it. But just one way or the other. Remember to do it. We've done stuff like this, a little bit like this before, but this is a little different. It's kind of related to the whole idea that if I go 2 steps out, I actually should catch a large percentage of the data. If it's a normal distribution, if it's a bell curve, and I go 2 steps out, I'll actually catch 95% of the data. So like men's heights are normally distributed. An average of 69 inches, standard deviation of 2 point something or other. So if I went up and down 2 standard deviations, I know what 95% of all American men, what heights they are between, and I would know that for sure, because they are normally distributed. It's kind of crazy. That's why we can make door heights so specific, and then you take hip width, and you can see why we make airplane seats, depending on the airline, if they give a shit about you or not, right? And most of them are the no category. Because they don't have to give a shit about you because they've all merged and we're all screwed and all through it. Such a hopeful message I have. So in the middle, I'm going to put the mean. And this time I'm going to go 2 steps. That's the formal definition right now. This is the formal definition of where unusual starts. 2 standard deviations up, 2 standard deviations down. Everything in the middle of that is usual, it's expected. Anything outside of that is unusual. So if I took men's heights, went up and down 2 steps, anything below or above those would be, I would go, whoa. It would be somebody taller than I expect, shorter than I expect. In the middle would be like, all right, you're a little shorter than me, but big deal. You're a little taller than me, but big deal. So it actually matches with our everyday idea of unusual. If somebody had a height that put them outside of 2 steps, we would do a double take. It would be unusual. It's not something we see all the time. So what's 2 steps up? We've got to add 2 of these. So if I do 6.688 plus 2 of these.
11.45.
11.45?
45.
451?
Yeah.
All right. Looks about right. And then if I go down 2 steps, so 6.688 minus 2 of these. Who is it?
1.925.
1.925. So everything in between here, if I got 2 people up to 11 people out of 44, that would be expected. But if I get 17 out of 44 randomly selected San Diegans, is that unusual or not? It is unusual because it's outside of what I expect. This is my expected area here. This is any number in here is usual. It's expected. Anything outside of here is a sign that something is different. So if I was taking 44 people from randomly selected areas, doing like a stratified thing, ooh, and I got a 44 people from one little area of San Diego, and it came out to be 17 of them, I would say, what is it about this area? Are cigarettes cheaper? Are conditions a certain way that makes people want to smoke? Or whatever. You guys with me? That's exploratory statistics. It's something unusual. Then you go in, you do some deeper digging with other analysis tools. A little bit. Oh, yay. So, yes, unusual for 17. 17 is way the hell out here. Way outside of what's expected. Okay, cool. I like it. So that's section 4.3. They talk about the binomial probability distribution, which is this formula up here. This kind of formula, right? Binomial. And then they talk about the mean and standard deviation for a binomial probability distribution. Ugh. I like it. So what we're about to get into after this, chapter 5 and chapter 6 especially, are really, believe it or not, the heart of statistics. Once we learn chapter 6, almost everything after that is going to depend on what we did in chapter 6. It's crazy. Trying to get you to understand that chapter 6 is really important. Right? I like it. I like it. Let me see. What else did I want to do today? I got through that quicker than I thought. I think it's pretty good. What is it? That's not too bad. I can let you guys out.
No.
I kind of almost want some.